Question says, explain clearly with examples the distinction between magnitude of displacement, sometimes called distance, over an interval of time and total length of path covered by particle over the same time interval. And in B we have magnitude of average velocity over an interval of time and the average speed over the same interval. Average speed of particle over time interval is defined as the total path length divided by the time interval. Next we have show in both A and B that the second quantity is either greater than or equal to the first. Second quantity refers to the displacement and the path. Yeah, in this section A we have second quantity as the total distance, and in B we have second quantity as the average speed. Second quantity is either greater than or equal to the first. When is the equality sign true? For simplicity, consider one-dimensional motion only. So we need to consider one-dimensional motion, and we have to distinguish between magnitude of displacement and the distance, sometimes called distance, and the total path covered by the particle. So let's have coordinate system which describes x and y coordinate of the path. This is the origin. So let the particle trajectory be something like this in case A, although this is two-dimensional motion. So this is one path, and the body covers up something a path like this, which is a zigzag motion from point O to point M. Now when we consider displacement, then displacement is defined as the difference in the position vector, final minus initial. So the position vector of final point would be something like this. And the initial vector is 0, so the displacement would be OM, and also it can be said that the shortest distance between the final point and initial point is termed as displacement, gives the magnitude of displacement. And displacement by the name also carries the direction, as displacement is a vector quantity. So when we talk about displacement vector OM, then it has magnitude, that is the shortest distance between O and M, and the direction, which tells us at what angle or with a reference coordinate system where the particle is, or in which direction the particle is heading. As far as the total length of the path is concerned, so the length of the path would be addition of this distance, which is the curve from point O to point M. So here we see that the distance, the length of path, is greater than the displacement or the magnitude of the displacement vector. This is always going to be true. Length is always greater than that of the displacement vector. Let us consider one-dimensional case here now. Imagine a particle starts from this point O and it travels in a straight line. In this case, we see that displacement as well as distance, or the length of the path covered by the body, is same. So when the particle is traveling in a straight line, then the total length of the path as well as the displacement is going to be same. Now consider second case, that this will the initial point where the body starts moving, and let us assume that particle goes from O to intermediate stop N, and then it travels back to a final stop M. So the length of the path would be ON plus MN. whereas displacement is just going to be OM. So here also we see that length of the path is greater than that of the displacement. So we can distinguish between length of the path and the magnitude of displacement, as length of the path is always greater than or equal to the magnitude of the total length of the magnitude of displacement, and also the displacement is a vector quantity and length of path is a scalar quantity. Now in B we have magnitude of average velocity over a time interval and the average speed over the time interval. We have to distinguish between magnitude of average velocity as well as the magnitude of average speed. So like here we had three cases. Here in case 1 we see that the path was little bit zigzag, and in second case we had rectilinear path, and in third case we had a path with retracted motion. So when we consider the average velocity in case 1, average velocity is defined as displacement, net displacement divided by time interval. This is also a vector quantity. So net displacement divided by time interval. Always we saw here that magnitude of displacement was less than that of the length of the path. So again here velocity is going to be less than, average velocity is going to be less than that of the average speed, where average speed is calculated as the length of the path traveled from initial to final point divided by time interval. Length of path divided by time interval. So we see that average speed is greater than the average velocity in first case. In second case we can say that since initial and final position, the magnitude of displacement, we saw that magnitude of displacement is equal to the length of the path. In this case given the same time interval, we can say that average speed is equal to average velocity. And in third case we saw that the displacement was less than that of the length of the path. So again average speed is greater than that of average velocity. Equality sign, also the question said when is the equality sign true? Equality sign is only going to be true when there is rectilinear motion, whereas the path is a straight line. Then only the magnitude of displacement and the total length of path is going to be equal. Also average speed is going to be equal to average velocity. Thank you.